Hi viewers, we will solve here one question related to maximum point. Here we have a diagram which shows the curve y is equal to x plus 5 bracket close square root of 3 minus 2x and its maximum point m. So first of all, we will find out the derivative of this curve. We can write the square root form as power 1 by 2, which is 3 minus 2x power 1 by 2. We will apply product rule as well. So derivative of this function is dy over dx. I will take or consider x plus 5 as first function, which is x plus 5. First function same, and the derivative of second function. So when you apply the derivative on second functions, bring down the power, which is 1 over 2, and subtract 1 from the power, means 1 over 2 minus 1. 1 over 2 minus 1, and then we will take the function itself derivative. So itself it is 3 minus 2x, that gives us 0 minus 2, and then plus second function, which is 3 minus 2x power 1 by 2 same, and the derivative of first, which gives me the derivative of x is 1 and derivative of 5 is 0. After this we will try to simplify. So if we simplify, this gives me x plus 5 minus 2x power 1 by 2 minus 1 gives me minus 1 by 2. And here we have minus 2 as well. So that minus 2 we can write here. And after that we have 3 minus 2x power 1 by 2. Then we try to simplify more further, cancel 2 and 2. And next we have, remember that there is a minus sign as well. So we can say that minus x plus 5. Here we have power negative 1 by 2. So that can be changed into positive. If you bring it down, it becomes 3 minus 2x plus square root of 3 minus 2x. After this, as we know that we are looking maximum point m, at maximum point derivative is 0. So left hand side would be 0. So once left hand side is 0, this can be written as like that. If you take this value of x plus 5 over square root of 3 minus 2x, other side it becomes plus, like x plus 5 over square root of 3 minus 2x is equal to square root of 3 minus 2x. And next, we will try to do as cross multiplication. This gives me x plus 5 is equal to, as you know that, or as you see that 3 minus 2x and 3 minus 2x are same. So we can cancel the square root form. That means we have lastly 3 minus 2x. So we will try to find out x value from here. If I take 2x from right to left, it becomes plus 2. So 2 plus 1x, 3x is equal to 3 minus 5. That means x is equal to minus 2. And lastly, we can say that x is equal to minus 2 over 3. So we will replace this value of x in a normal function or curve y, and we will see what is the value of y when x is minus 2 over 3, and that is our maximum point which we are looking, our exact coordinate of m. So when at x is equal to minus 2 over 3, y is equal to minus 2 over 3 plus 5 square root of, or we can say that 3 minus 2 into minus 2 over 3 whole power 1 by 2. I will try to simplify. Here we have 5, 5 3s are 15, 15 minus 2, 13 over 3, bracket close. This becomes 3 minus minus plus 4 over 3 whole power 1 by 2, and then y is equal to 13 over 3, and this becomes 3 3s are 9, 9 plus 4 13, 13 over 3 power 1 by 2, which we can say that more further, like 13 square root of 13 over 3 square root of 3. You can solve more further, but this can be a one answer of y. And as we are looking x, y value or coordinate, exact coordinate of m. So the exact coordinate of m is, the value of x is minus 2 over 3, whereas the value of y is 13 square root of 3 over 3 square root of 3. Next, we have the second part of this question, which is using the substitution concept. U is equal to 3 minus 2x. Find the integration, the area of the shaded region are bounded by the curve and x-axis. So give your answer in the form a square root of 13, where a is a rational number. So we are looking the point, this one along x-axis, the lower and the maximum point. So for that x axis y is always 0. So our normal curves become like y is equal to x plus 5 and 3 minus 2x power 1 by 2. At x-axis y becomes 0. So we can say that x plus 5, 3 minus 2x power 1 by 2 equals 0, which means x plus 5 equals 0 and x 3 minus 2 x power 1 by 2 equals 0. So by taking square on both sides, this becomes 3 minus 2x is equal to 0. So 3 is equal to 2x, or we can say that x is equal to 3 over 2. And here we have x is equal to minus 5. So we have two values, which is negative 5 and 3 over square root of 3 over 2. That will help us to find the area under the curve by using integration concept as well as substitution. So next step, now we will find the a shaded area. For shaded area, we will take the integration of this function, that is minus 5 to 3 over 2, and remember that our curve was x plus 5, whereas the second value was 3 minus 2x power 1 by 2 dx. So as they said, we will apply using by substitution concept. Even they give us the hint in the question itself, u equal 3 minus 2x. So we'll take the help of this. The first thing is u, which is equal 3 minus 2x. So from this, we can find 2x as well. If you take 2x other side, it becomes plus 2x. And we can say that 3 minus u, or x is equal to what? 3 minus u over 2. And the other thing is, if we take the derivative of this function, which is du over dx, du over dx. So derivative of 3, of course, 0. And this gives me minus 2. Or we can say that dx, if we are looking the value of dx, or we simply say that first du equal minus 2 dx. Or if you are looking dx equal what? So dx equal, of course, minus 2 will divide other side. So minus 1 by 2 du. So these values we will replace later. But remember, when you substitute, your limits are also changed. For example, when x is minus 5, when x equal minus 5, what u becomes? So we will replace x5 here. Then u becomes what? 5 twos are 10. And remember that it is minus 5. So plus 10 plus 3 gives me 13. Means u becomes 13. And if we have x value 3 by 2, the second value of x is 3 by 2, then what is the value of u? Or u becomes what? So remember that if you replace here 3 by 2, which is we can cancel 2 and 2, and then plus 3 and minus 3 gives me 0. So u becomes 0. So now our limits are 13 to 0. In place of minus 5 to 3 by 2, we will write 13 to 0 when you substitute. So our required equation will be, first, in place of minus 5, I would say that 13. And in place of 3 by 2, it becomes 0. And after this, we have x plus 5. So in place of x, I will substitute x equal 3 minus u. So 3 minus u over 2 plus 5. And then what we have 3 minus 2x, which is exactly u. If you check carefully in the start of the question, u equal 3 minus 2x. So u, but it is the power, what is it? Which is 1 by 2. And next we have dx. So we found here dx as well. That is minus 1 by 2 du. So after substituting all these, we will try to simplify and apply the integration as well. So the next step is 13 to lower limit 13 and upper is 0. I will try to simplify inside. The inside function becomes u over 2. We can say that r minus 1 by 2 u bracket close. And next one is u power 1 by 2. Again, next we have minus 1 by 2 du. Still we simplify more further. Remember that this two, uh, if I check carefully, this one, look, I'm gonna solve also. Like if you check carefully, 5 twos are 10, and 10 plus 3 13. So this is 13 over 2, and minus 1 over 2, that is correct. And now remember there is a 1 by 2, so 1 by 2 comes common. 1 by 2 here, 13, upper limit 0. We have now 13 minus u and u power 1 by 2, and this one we have minus 1 by 2 du, and this 1 by 2 and 1 by 2 we will multiply, it becomes 1 by 4. So we can say that minus 1 by 4, 13 to 0 it is, and multiply u power 1 by 2 inside as well, which gives me 13 u power 1 by 2, and when you multiply u power 1 with 1 by 2, so it gives me 3 by 2. That means u power 3 by 2, and with them we have du. Now we can apply the integration as well. So minus 1 by 4, if I apply integration first, like on 13 u power 1 by 2, so we can apply the power rule, like add 1 in the power, means 1 by 2 plus 1, that gives me 3 by 2, and same thing we will divide. Next we have u power 3 by 2 plus 1. So that gives me 3 by 2 plus 1 gives me 5 by 2, like 2 ones are 2, 2 plus 3, 5. So 5 by 2. The rule says we have to divide the power as well, 5 by 2. And lower limit is 13 and upper limit is 0. Now we'll apply the upper as well as lower, but before applying, you can still simplify more further. One more step, 1 over u, 1 over 4. This 3 over 2 is basically changed into reciprocal when you bring it up. So 13 twos are 26. That means I have 26 over 3 u power 3 by 2 minus, this becomes 2 over 5 u power 5 by 2. Now the lower and upper limit are same, 13 to 0. After this, we will apply the limits, and once you apply the limit, which is equal 1 by 2, upper limit is 0, so straight away these values would be 0, like 0 minus 0. Then I'm going to apply the lower limit, which is 13. So 26 over 3, in place of u, I would say that it is 13, and the power is 3 by 2, minus, then we are going to apply 2 over 5. 2 over 5. In place of u, we have 13 and power 5 by 2. After this, we will try to simplify more further and see we have minus 1 by 4. Next step we have this, basically 26 is 13 multiplied by 2. So 13 we can simplify with the power of 13 power 3 by 2. So 3 by 2 plus 1 gives me 5 by 2. It means this can be 2 over 3, 13 power 5 by 2. And here we have minus minus plus, 2 over 5, 13 power 5 by 2. So once it is done, then we move next step. We can say that minus 1 by 4. And here we have, we can take as LCM. If 5 threes are 15, so upside 15, 5 twos are 10. So minus 10, 13 power 5 by 2, and here 5, 3, 3 twos are 6. So 6, 13 power 5 by 2. I took the LCM as well, then minus 1 by 4. Minus 10 plus 6 gives me minus 4. So minus 4, 13 power 5 by 2 over 15. And then we can multiply, or we can cancel as well this 4 and 4, minus minus plus. So we have lastly 13 power 5 by 2 over 15, or more further we can say that it is, if you divide into parts, 13 power 5 by 2. So this could be 1. Basically, if I say 13 power 2 multiply 13 power 1 by 2, that gives me 2 plus 1 by 2 gives me 5 by 2. So is this 13 square is basically 169. So that 13 power 1 by 2, you can still write same over like square root of 13 over 15. This is the kind of last form which they want as well, a square root of 13. Or we can say that 169 over 15 and square root of 13. So this is exactly the same form what they want from. Next question is related to vector, and in this question we have the points A and B have position vectors. So these are basically position vector of A and B respectively, or we can say that OA and OB. So if we have these two position vectors, we will find out the direction vector, which is AB, and later on we will say the L equation is what, and then we will compare with R by making the parametric equations to show that the L does not intersect the line passing through A and B. So as we know that the AB is equal OB minus OA, and OB is given, which is 2 minus 1, 2 minus 1, 1, and OA is 1, 2, minus 2, and we are looking AB. So AB equal 2 minus 1, 1, minus 1 minus 2 minus 3, and 1 minus minus plus 2 gives me plus 3. So this is my required direction vectors. So with the help of this direction vector, we can find a required equation or vector equation AB. So the vector of AB is R is equal to, we can suppose any position vector OA or OB, 1, 2, minus 2, 1, 2, minus 2. Then we will take variable from our mind like T. Here we have mu. Okay, so you can take any other, like I consider it as T. And then direction vector, what we find out here, AB. That one is 1, minus 3, 3. From here we can make an vector equation, and that vector equation we will compare with this to find out L does not intersect. That we will see at the end. So if you try to move one further step, this becomes 1 plus T, 2 minus 3T, and lastly we have minus 2 plus 3T. So then this vector equation I will compare with the second, which is here R equal, from here you can say that 1 plus 2 mu and then minus 1 plus minus 3. So I will write here, I'm going to consider let. First I'm going to write from here, which is first position vector is 1 and then 2 mu plus 2 mu, and then for j vector we have minus 1, 3 plus 4 mu, and we will compare this with the vector equation R, and that one is 1 plus t, 2 minus 3t, and once we compare, now we have these equations like 1 plus 2 mu is equal to 1 plus t, and then second you can say that from here we can find out t as well, like for example t is equal to 2 mu. If you take one other side it becomes minus 1, so plus 1 minus 1 will be 0. So this is your first equation. Second parametric, we can say that -1 minus 3 mu is equal to 2 minus 3t. From here, if we try to find t value, so bring 3t from right to left, it becomes plus 3t. And then this 3 mu we can take other side, so it is plus, and this becomes plus 1. That means 3t is equal to 3 mu plus 3. If you take 3 common from both sides, it becomes t is equal to mu plus 1. So this is equation 2. Now we will try to find out the value of t and mu, and then we will replace in the last one to check either they are equal or not. If they are equal, they will intersect. If they are not equal, we will say they does not intersect. So try to find out, like for example, here look, t is equal to 2 mu. I will replace here in 2 in place of t. 2 mu is equal to mu plus 1, and then 2 mu minus mu equal 1. That means mu equal 1. So with mu value of 1, we can replace here to get t. That means t 2 into 1, so t is equal to 2. Now we find out the value of t as well as mu, and we will replace in the third parametric equation, which is 3 plus 4 mu is equal to minus 2 plus 3t. If I say left hand side, that gives me 3 plus 4 mu value, we know 1, that gives me 7. And if I check the right hand side, that gives me minus 2 plus 3 into t is 1. In right hand side, we have the value of t is 2. So 3 twos are 6. 6 minus 2 gives me 4. But remember that left hand side is not is equal to right hand side. Means 7 cannot be equal to 4. So at the end, we can say that line AB and line L does not or do not intersect. Okay. Do not. I hope so it is clear.